Hello everyone. In this video, I am going to explain about Schrodinger's wave equation. Schrodinger equations are of two types. They are Schrodinger time independent equation and Schrodinger time dependent equation. Firstly, I will discuss Schrodinger time independent equation. I will derive the Schrodinger time independent equation first. Okay, for this, let us start with the wave equation. We know we know the Maxwell's wave equations. Maxwell's wave equation as nabla square psi, which is basically the wave function. It is basically the function of r and t is equal to 1 by u square del square psi by del t square. Again, here psi is the function of rt. So in general, in simple case, we can write it as nabla square psi is equal to 1 upon u square del square del square psi upon del t square. We know this. Okay, but keep in mind that here this wave function is basically the function of r and t. R is the space coordinate and t is the time. You know about that. Let us consider this as equation number 1. Okay, the solution of this equation is of the form. We can write it as the solution of equation 1 is of the form like this, psi. We can write that because the solution of this wave equation means the value of psi is the solution. So that's why its solution can be written as like this: psi, which is the function of position coordinate and time, psi rt is equal to psi naught, which is the function of r only, and e to the power minus I omega t. Okay, in general, we can write it as psi is equal to psi naught e to the power minus I omega t. But keep in mind that this psi is basically the function of r and t, and psi 0 is the function of the r only. Okay, and where this is called, where psi naught is called, where psi naught is called amplitude at that point, it's called amplitude at the point considered, Okay, so now what we need to do is that we have to find the value of this one, del square psi by del t square, and put this value to this equation number 1, and then we will get the equation. Okay, for this differentiate. Let us take this as equation 2, differentiate equation 2 with respect to time, with respect to t. Okay, so then what will be del psi by del t is equal to psi naught is basically the function of r only, space. It depends only on the space coordinate. Basically this psi represents the displacement. Okay, and so, and psi naught is the maximum displacement we can consider. So, and if we take the derivative, what will be its derivative? Minus I omega and e to the power minus I omega t. This will be the first order derivative. Okay, in this way but we need actually the second order derivative. That's why the second order derivative, del square psi by del t square is equal to okay, psi naught minus I omega square e to the power minus I omega t. Okay, then we can write this as del square psi by del t square is equal to, this minus square means plus and I square means minus omega square psi naught e to the power minus I omega t, and we can write it as psi naught e to the power minus I omega t. What does it imply? Del square psi by del t square is equal to minus omega square, and this will be equal to psi. Basically this is the psi rt. Okay, and now put this value to equation number 1 here, del square psi by del t square. Okay, now putting this value in equation number 1, then what will be our equation number 1? In equation number 1, basically we have nabla square psi is equal to 1 by u square del square psi by del t square, and then now put the value nabla square psi. This psi is basically the function of r and t. Okay, keep in mind this. Okay, 1 by u square, and what is the value of this del square psi by del t square? Means minus omega square psi. Okay, minus omega square and psi. Okay, so you can just rearrange this term. Nabla square psi is equal to minus omega square divided by u square and psi. Let us consider this as equation number 3. Okay, now as we know that basically omega is equal to 2 pi f. Okay, omega equal to 2 pi f, we know that. And again this omega is equal to 2 pi, as you know that b equal to f into lambda. Then from this you can write f as b by lambda. Okay, then what you can put? You can put just in this particular case you can write as the velocity is u, so we can write u divided by lambda. Okay, now but we need basically we need the value of omega by u. Okay, omega by u, then what will be the value of omega upon u? If this u will go to the denominator side, omega divided by u is equal to 2 pi by lambda. Okay, now just put this value to the equation number 3. Okay, then equation 3 becomes, then equation 3 becomes, we can write that nabla square psi is equal to minus u omega square by u square, means omega divided by u is equal to 2 pi by lambda. It means that 2 pi by lambda square and psi here. Okay, now we can write that nabla square psi is equal to minus 4 pi square divided by lambda square, 4 pi square by lambda square and psi. Okay, this minus become plus if we take this term to the left hand side. Nabla square psi plus 4 pi square by lambda square psi is equal to 0. Okay, let us just put this equation as equation number 4. Okay, and again we know that lambda is equal to h divided by p. It means that and lambda is equal to h upon mv or mu. Just I just momentum p is equal to m into v or simply mu. Then put this value to this equation number 4. Then equation 4 becomes, becomes what? Nabla square psi plus 4 pi square divided by lambda. Lambda means h square m square u square psi is equal to 0. This is what we have. 4 pi square by h square m square u square psi is equal to. Let us take this equation as equation number 5. Now what we have, as we know that, we know kinetic energy is basically equal to the total energy minus potential energy. We know about this. Kinetic energy equal to total energy E minus V, and kinetic energy is basically 1 by 2 mu square or mv square, you can write, is equal to E minus V. Then mu square will be, this 2 will go to the right hand side in by cross multiplication, E minus V. But actually you need the value of m square u square here. So what you need to do, you can just multiply by m on both sides. Multiply by m on both sides. Okay, on both sides. Then what happen? The left hand side becomes m square u square, right hand side becomes 2m and E minus V. Okay, now just put this value to the equation number 5 in the place of m square u square. Then equation 5 becomes, what? In equation number 5, nabla square psi plus what are the terms over there? 4 pi square by h square, 4 pi square by h square, and the other terms, and m square u square. You just put that 2m E minus V and the psi. Okay, psi is over there already, and the right hand side becomes already 0. So okay, now what you can write, I just show you that h cut is basically h by 2 pi. Okay, h cut is basically h by 2 pi. So nabla square psi plus you can just write that h square by 4 pi square. You can write this term as this, because this 4 pi square is in the upper side, and when it will go to the down, this will be like this, 1 divided by h square divided by 4 pi square, and 2m E minus V and psi is equal to 0. Okay, then nabla square psi plus 2m, what will be the value of this term? As we know that h divided by 2 pi is equal to h cut, then here is h square by 4 pi square. It means that it is 2m by h cut square, 2m by h cut square, and E minus V psi is equal to 0. Okay, so in general we just write that this equation nabla square psi plus psi here means psi RT, 2m by h cut square E minus V psi is equal to 0. This is basically the Schrodinger's time independent equation. This equation is called Schrodinger's time independent equation. Okay, Schrodinger's time independent equation, because there is not the any time here. Nabla square means the differentiation with respect to position coordinates only, and as there is no term, this equation is very much important, and this is called Schrodinger's time independent equation. Okay, now let us move ahead and just try to derive the Schrodinger's time dependent equation. Okay, now in deriving the Schrodinger time independent equation, we will start with the Schrodinger time independent equation, and we will just eliminate the value of E. Eliminate the value of total energy from that expression. Okay, we know, we will start with this. We know from Schrodinger's time dependent independent equation, we have nabla square psi plus 2m by h squared square E minus V psi is equal to 0. This, consider this as equation number 1, and keep in mind that this psi is basically the function of position and time. Okay, now basically Schrodinger time dependent equation can be obtained by eliminating this E. Okay, so for this, as we know that also we already stated that psi is equal to basically psi naught e to the power minus I omega t. Okay, where psi naught is the function of position coordinate only. Now del psi divided by del t is equal to what will psi naught minus I omega e to the power minus I omega t. This is the first derivative. If we perform the first derivative, we will get the term like this, and then okay, I will move ahead, and then this value basically del psi by del t is equal to, and in place of omega basically, okay, I will just write here minus I. In place of omega, I just write 2 pi f, and here is psi naught e to the power minus I omega t. Okay, and again what I have, del psi by del t is equal to minus I and 2 pi. There is one expression, I think you all know about that, E is equal to hf. This is the photon's energy. Then what will be the value of f? From here, f is equal to E divided by h. Okay, so we can write that E by h and psi naught e to the power minus I omega t. Okay, then you can write this as psi, because psi naught e to the power minus I omega t means psi. Simply del psi by del t is equal to basically minus I, and here it is basically you can just write in this way, 2 pi E divided by h, and this is simply you can write psi. Okay, basic, because if you look here, psi naught e to the power minus I omega t is equal to the psi, so that is why you just replace that value over here. And now I will do like this, del psi by del t is equal to, you just perform that, just here minus, you can just multiply by I in the denominator and numerator, and here also I, because there's no problem, this I will cancel with one I, and one I only remaining there, and minus is already there. Okay, and then again you just put this 2 pi below h. Okay, you can write this as h divided by 2 pi, and there is the value of psi. Okay, now if I move ahead, what will I get? I just get that here basically del psi by del t will be equal to I square mean minus 1, and this minus and this minus become plus, and simply what I get, E, and this is here is I, and h by 2 pi means h squared and psi. Okay, so then what will be the value of E psi? The value of E psi will be, I h squared del psi by del t. E psi is equal to I h squared del psi by del t. Okay, then now put this value in equation number 1, in this equation. Okay, putting this value putting this value in equation 1, then what will happen? Nabla square psi plus 2m by h cut square e minus b. I mean to say that we can write in this way also. We can write, little, I will arrange little bit. I will just take this to the right hand side and e minus v psi. Okay, and now if I perform, Nabla square psi is equal to minus 2m by h cut square and e psi, and this minus minus become here it, okay, no necessary, you can just take this minus from here, and you can just take this minus to the left hand side here, and 2m by h cut square e psi minus 2m by h cut square, simply 2m by h cut square v psi. Okay, and actually you don't, you can just take this h square to left hand side and 2m to the right hand side by taking the common. So I think this term is not necessary here. You can carry from this term also, but no problem at all. You can do that. Minus h cut square by 2m, and Nabla square is over here, is equal to e psi minus v psi. Simply you can write this 2m by h cut square, if we try to take this term to the left hand side, it will becomes minus h cut square divided by 2m e psi minus v psi. Okay, now put the value. If you put the value like h cut square by 2m, Nabla square psi is equal to I h cut del psi by del t, because it is the value of e psi here. E psi is equal to I h cut del psi by del t. So, and then again it is v psi. Now what you can do is, you can just take this v psi to the left hand side, minus h cut square divided by 2m Nabla square psi plus v psi is equal to I h cut del psi divided by del t. Okay, and Nabla minus h cut square 2m minus Nabla square psi. Okay, now you just can write this as minus h cut square by 2m Nabla square plus v, and psi is equal to I h cut del psi by del t. Actually this equation is called Schrodinger time independent equation. This equation is called Schrodinger's time dependent equation. Okay, time dependent equation. And keep in mind that this operator, basically here the operator this one, minus h cut square by 2m Nabla square plus v, this is equal to the h, and then this h is basically called the Hamiltonian. This h is called Hamiltonian. Okay, so that is why this equation sometimes can also be written as like this. This implies that h psi is equal to e psi also. Why it is so? Because this term, if you look carefully, this term minus this term become Hamiltonian h, and basically I h cut del psi by del t is equal to e psi basically. Okay, but actually this represents the Schrodinger time dependent equation, and this is the Hamiltonian. This is all about the Schrodinger's time independent and Schrodinger's time dependent equation. So thank you very much for watching this video. If you have any comments, suggestions or feedback, please write in the comment section. So thank you very much.